Firstly, what is complex number? Geometrical representation of a complex number, equality of complex numbers, conjugate of a complex number, modulus of a complex number, algebraic operation of complex number, lastly powers of I. What is complex number? A complex number z equal to a plus iota b is defined to be an order pair of real number a comma b. In order pair AB, the first component A is said to be the real part of Z, and the second component B is said to be imaginary part of Z. A plus IB is a complex number. The first part always called real part, and the second component is called always imaginary part. The great mathematician Euler first introduced the symbol iota. The value of I equal to square root of -1. Next, geometrical representation of a complex number. Let Z equal to a plus iota b equal to order pair of AB be any complex number. The first coordinate axis, that is x axis, always known as the real axis, and the second coordinate axis, always known as imaginary axis. So real numbers are represented as a point on a line, but complex number can be represented as a point on a plane. This is a plus iota b. This is a complex number. Now I discuss equality of complex number. Two complex number z1 equal to a1 plus iota b1 and z2 equal to a2 plus iota b2 are equal if and only if a1 equal to a2 and b1 equal to b2. That is, real part of z1 equal to real part of z2 and imaginary part of z1 equal to imaginary part of z2. For example, if z1 equal to 2 difference iota y and z2 equal to x plus 3 iota are equal, find x and y. Now easily we can show that if z1 or z2 are equal, then real part of z1 equal to 2 and imaginary part of z1 equal to -y, and real part of z2 equal to x and imaginary part of z2 equal to 3. So we have x equal to 2 and y equal to -3. Now I describe conjugate of a complex number. Let z equal to a plus iota b be a complex number. The conjugate of z always denoted by z bar and is defined by a difference iota b. Given a complex number a plus iota b, then its conjugate equal to a difference iota b. If a difference iota be any complex number, then it conjugate a plus iota b. Geometrically, the conjugate of z is the reflection of the point z in the real axis. Just we consider the figure. This is a complex number and this is a real axis and this is a imaginary axis, and this is a conjugate of z whose value equal to a difference iota b. So the conjugate of z is the reflection of the point z in the real axis. Go to next slide. Modulus of a complex number. The modulus of a complex number z equal to a plus iota b is denoted by mod z and is defined as mod z equal to square root of a square plus b square. What is a? A equal to real part of z and b equal to imaginary part of z. So mod z equal to square root of real z square plus imaginary z square. If now we consider two example. If z1 equal to 3 difference 4 iota, find modulus of z1. Here we compare z1 equal to a plus iota b. Then we have a equal to 3 and b equal to -4. Using the definition of modulus of z, then we have mod z1 equal to 3 square plus -4 whole square equal to root over 25 equal to 5. Similarly, if z2 equal to -5 plus 2 iota, then real part of z2 equal to -5 and imaginary part of z2 equal to 2. Therefore, mod z2 equal to -5 square plus 2 square root. Therefore, mod z2 equal to square root of 29. 25 plus 4, 29. If we consider the figure, then we can easily see that mod z equal to square root of a square plus b square. Suppose z equal to a plus iota b be any complex number, then this is a real part of z and this is a imaginary part of z. Therefore, this is a right angle triangle and this is a base whose value equal to a, and this is length whose value equal to b. Therefore, this is a hypotenuse. Therefore, from the right angle triangle property, we write hypotenuse square equal to base square plus perpendicular square. Therefore, a square plus b square. Therefore, mod z equal to square root of a square plus b square. Now I describe 4 property of a complex number. Firstly, when adding two complex number, add the real part together and add the imaginary part together. For example, 3 plus 7i plus 8 plus 11i. Here real part of first complex number is 3 and the real part of second complex number equal to 8. Therefore, we find that 3 plus 8 equal to 11 plus 7 plus 11i equal to 18i. Next, go to next slide. When subtracting complex number, be sure to distribute the subtraction sign. Then add like part. 5 plus 10i difference 15 minus 2i. Then we can write real part 5 difference 15, that is minus 10, and plus 10i plus 2i equal to 12i. Go to next slide. When multiplying complex number, use the distributive property and simplify. 3 difference 8i into 5 plus 7i. Then we have 3 into 5 equal to 15 plus 3 into 7i equal to plus 20i. Difference 8i into 5, difference 40i, difference 56i square. Using the property of I square, we have I square equal to minus 1. Putting the value of I square, we have 15 difference 19i plus 56. Then we have 15 plus 56 equal to 71 difference 19i. To divide complex number, multiply the numerator and denominator by the complex conjugate of the complex number in the denominator of the fraction. 7 plus 2 iota divided by 3 difference 5 iota. Taking the conjugate complex of 3 difference 5 iota, we have the conjugate of 3 difference 5 iota is 3 plus 5 iota. Multiplying denominator and numerator by 3 plus 5 iota, we have 7 plus 2 iota into 3 plus 5 iota divided by 3 difference 5 iota into 3 plus 5 iota. After simplifying, we have 21 plus 35i plus 6i plus 10i square divided by 9 plus 15i difference 15i minus 25i square. Putting the value of I square equal to minus 1, we have 21 plus 41i difference 10 divided by 9 plus 25. After simplifying, we have 11 plus 41i divided by 34. Go to next slide. Lastly, I discussed the powers of I. Previously, I discussed I square equal to minus 1. Then multiplying both sides by I, we have I cube equal to minus I. Again, if we multiply both sides by I, we have I to the power 4 equal to minus I square. Using the value of I square equal to minus 1, we have I to the power 4 equal to 1. Thank you.